This video is brought to you by electricalexamcoach.com, offering the #1 electrical exam prep series. You can take our paid version with the Unlimited Testing Center, but you can also take our free version that is completely free without the Unlimited Testing Center. Also, if these videos have been helping you at any time, you can also go there and pay it forward to see it head on to the next generation. I am the Electrical Code Coach. Let's go ahead and get to it. Hey y'all, what's up? It's the Electrical Code Coach here, and I'm super excited to be back with you. This is week 4 of our Electrical Code Coach training program. I'm super excited to be a part of your journey. This week we're going to be learning about HVAC VAs, your heating, venting, and cooling VAs as far as load calculations. Then we're going to do our first whole house load calculation. I'm super excited for you. Then we're going to learn all about optional calculations. I am the Electrical Code Coach. Let's get to it. All right, y'all, I'd like to start each week with a icebreaker question. We do this class in person, and that's how I get to know you guys. But, we can't do this in person, and we're doing this online, but I still want to get to know you. So answer the icebreaker questions down in the comments below. All right, so the first one is, if you had to choose another career, what would it be? So let's imagine tomorrow they invent, Tesla's coil, and it gives everyone wireless electricity, and they don't even need a serviceman. What would you go be? Explain it down in the comments below. And the second question is, what is going to be the greatest benefit of you getting your license? It's all about the reasons. The reasons keep you driving when the days are hard and the days are long and you feel like you want to quit and you want to give up. Why are you going for your license? Is it to break, the chains of your family? Is it to start a new legacy? Is it to, be able to earn and provide on that level that you want to? So just remember the reasons you're doing this. So drop down in the comments below. What are going to be the greatest benefits of you getting your electrical license? Let's get to it. All right, y'all, so we have a few final steps to learn before we do our whole house load calculation. I'm super excited you made it this far. I can't wait till you can see the whole thing in one piece. We're almost there. Let's get to it. All right, so now we're going to learn about our HVAC VAs. This is for your heating, venting, and cooling VAs that you're going to use for your whole house load calculation. And the thing that we have to watch out for is that we're only going to use one or the other, unless for some reason your question states that both are going to be running at the same time, or maybe even your real world scenario, both of them are going to run at the same time. But pretty much across the board, I've never seen anything but either or. So you're going to, with the standard method, you're either going to choose the larger of the two. It's either going to be the heating or the cooling. Let's check it out. How many VAs would you calculate for an 18.2 amp air conditioner compressor with a 1.8 amp blower and a 10 kW heat strip, all rated at 240 volts on a house in the Ridges? Remember, we're going to use the larger of the two. So let's figure the air conditioning first. So we're going to add the amps of the compressor and the blower motor together, and that will let us know the total that it takes to run the AC. We have 18.2 plus 1.8. That's going to give us 20 amps. Now we need to convert that over to VAs. In order to do that, we're just going to apply Ohm's law like we've learned. So we take our 220 amp and we multiply it by 240 volts because it was stated in our question that they're all rated at 240 volts, and that's going to give us 4,800 VAs or 4.8 kVA. Now we can set that to the side and we'll calculate the heat. All right, so we have 4.8 kVA of cooling, and we have 10 kW heat strip, which is equivalent to 10 kVA. But we have to remember to add in the blower motor because it needs it too to blow the heat around. So we take our 1.8 amp motor, we multiply it by the voltage, that's going to give us 240 volts. And if we multiply those, that's going to give us 432 VAs that will actually add to our heat strip. So that makes our total 10,432. And what we're going to do is select the larger of the two. And in this case, it's going to be the heat. And it's almost always the heat when you're actually testing. But let's go ahead and look at another example just so you know how to work both of them out. And we're going to select C. Great job. How many VAs would you calculate for a 28.2 amp air compressor with a 3.2 amp blower and a 6 kW heat strip, all rated at 240 volts at a house in Flag Pond? All right, so we're going to use the larger of the two. So first, let's calculate the air conditioning. We're going to add the amps of the compressor and the blower motor together. That's going to give us 31.4 amps. Now we just need to use Ohm's law to find out how many VAs. So we take our 31.4, multiply it by 240 volts. That's going to give us 7,536 VAs or 7.54 kVA. Now we set that to the side. We know that our heat strip is a 6 kW, so let's add the blower motor. So we just take our 3.2 amp blower motor, we multiply it by 240 volts. That's going to give us 768 more VAs that we need to add. So we take and add that up. That gives us a total of 6,768 VAs. And in this case, we're going to select the larger, which is the cooling, and we're going to select B. Great job. All right, y'all, there's just one more thing that we need to learn about before we do our first whole house load calculation, and that's how to apply the demand factors to our general lighting and our small appliance and laundry circuit calculation. Do you guys remember how many VAs it is to calculate per square foot for our square foot VAs? That's right, it's 3. And also, do you remember how many VAs total that we add for our two small appliance and one laundry circuit? That's right, it's 4,500. So we're going to learn how to apply the demand factor to just that section, and then we've got the whole puzzle and we can move on. All right, y'all, now we're going to learn how to apply the demand factors to the general section of our calculation, which includes our square foot VAs and the 4,500 VAs for our two small appliance and one laundry circuits. So let's head over to table 220.42. It's going to be on page 72 of the 2017, and it's going to be on page 76 of the 2020. Pause the video now, and you can pick back up when you get there. All right, so when we find ourselves in table 220.42, first thing we're going to do is we're going to stop and we're going to read the black bold heading to make sure we're in the right table. It says lighting load demand factors. Boom, I feel like we're in the right table. And then remember, we always read our tables from top to bottom and left to right using the black bold headings to navigate. So let's start at the left-hand side. The first black bold heading we come to says type of occupancy. And if you look down through there, it's pretty self-explanatory. If that type of occupancy is listed in there, then you're allowed to use, these demand factors. Okay, the second black bold heading to the right says portion of the lighting load which the demand factor applies. Okay, so it's broke down in portions, and don't be overwhelmed by it. We're going to break it down step by step, and hopefully I've created the easiest way to work through this part of the load calculation. Then on the far right, it says the demand factor. That's our last black bold heading, and that's the demand factor that you apply. But you guys are starting to be pros by now, really, understanding that this is just a multiplier, isn't it? So we're just going to multiply using these values, and we're going to work through it. So let's go ahead and look at this table. So on the far left-hand side, we're dealing with dwelling units. Okay, so now let's go over to the second column and kind of break down and walk through how to do this. Then we're going to do an actual calculation. Okay, so step 1 says the first 3,000 VAs, you're going to take those at 100%. Okay, and I'm going to teach you how to set those to the side. Okay, all right. Step 2 says we're going to take the next 3,001 up to 120,000. And we're going to multiply that by 35%, okay? If there's anything left over that, we would do meaning over 120,000, okay? If there's anything over that, we would take that portion at 25%, okay? But most often, when you're doing a single-family dwelling or even a small multifamily dwelling unit, you're not going to get that high in the VAs. But we do have some of that in our program. All right, so step 3, we're going to add them back together. So step 1, we take the first 3,000 VAs at 100%. Step 2, we take the next 3,001 up to 120,000 at 35%. And then step 3, we just add those two numbers back together, and that gives us our total VAs for our general section of our load calculation. It may sound overwhelming now, but I'm confident in you, and I believe that once we work through this, you're going to be a pro at it. Let's get to it. What is the total VA you would calculate for a 1,600 square foot home, including the small appliance circuits and the laundry circuit up Piney Grove Road? Okay, so the first thing we're going to do is we're going to calculate our general square foot VAs. So we'll take our 1,600 square foot, we multiply them by 3 VAs per square foot, and that's going to give us 4,800 square foot VAs. Now we just add it with our required 2 small appliance and 1 laundry circuit VAs. And if you remember that we have to count 1,500 for each. So we take 3 multiplied by 1,500. That is going to give us 4,500 VAs. I do want to note that anytime you're doing a load calculation, do your square foot VAs and then just add 4,500 to it. In your questions, it's almost never going to mention the small appliance and the laundry circuit. They just assume that you know that, so you have to remember to add those 4,500 VAs. If we'll commit that to memory, we just add the 4,500 for the small appliance and the laundry circuit to each question. Okay, so we just take and add those two together. That's going to give us 9,300 VAs. Now that we have our total VAs in any question, what do? We're going to check for demand factors. So up until this point, I had not showed you how to apply demand factors to any part of the whole house load calculation. So we're going to do that now. In your whole house load calculation, you will use table 220.42 again for your general square foot VAs and the small appliance laundry circuit when doing a whole home load calculation. And we're going to practice this a bunch, so don't worry. So we had 9,300 VAs total. Table 220.42 tells us that we take our first 3,000 at 100%. So in step 1, you take your 9,300 total minus 3,000 that you have to calculate at 100%, and that is going to give us 6,300 VAs. Then it tells us to take the next 301 up to 117,000 at 35%. So we just take 6,300, multiply it by 0.35, and that is going to give us 2,205 VAs. Then, step 3, we just add them together. So we take 3,000, we add the 2,205 VAs, and that's going to give us 5,205 VAs. So we select D. What is the total VA demand you would calculate for a 1,600 square foot in a home with the following loads? So I just want to encourage you guys, everything you've learned up until this point, now it's all coming to the culmination. We're going to do a whole house load calculation. So we have a garbage disposal, dishwasher, water heater, dryer, range, heating, cooling, and you got some options. So we have 1,600 square foot. We have the following loads, and I'm going to teach you guys how to do this. If you do it this way every time, you'll be able to do it. You'll be able to use it out in the field and also use it to pass your examination. Step 1, you always figure your general square foot VAs and your small appliance laundry circuit VAs first. So first calculate your general square foot. Take your square foot multiplied by 3 VAs per square foot for dwelling units. That's going to give you 4,800 square foot VAs. Then you just add 4,500 VAs, and that's going to cover your 2 required small appliance and your laundry circuit. If you notice, our question mentioned nothing about small appliance and laundry. They just assume that you know that. Then we add them together. That's going to give us 9,300 total. Okay, so we have 9,300 VAs total, but we need to stop now and go ahead and apply demand factors to this portion of the calculation. So we head to table 220.42. We take our first 3,000 at 100%. In step 1, you take your total and minus the 3,000. That's going to give you 6,300 VAs. In the next step, you're going to take the next portion and multiply it and get 35% of it. So you take 6,300 multiplied by 0.35, and that is going to give you 2,205 VAs. Then all you have to do in step 3 is add the 3,000 that you set to the side to the reduced load, and now you have 5,205 VAs. Now you go ahead and put that at the top of your calculation. If you structure your question like this, you'll be able to move down as you go, and you'll see what I do here. Now the fixed appliances. We have a garbage disposal, a dishwasher, and a water heater. In this case, there's only 3, and we need 4 or more to apply the 75% rule, so it does not apply. So we just add them together. Okay, and that's going to give us 5,500 VAs. Okay, now we're going to do the dryer. Now the dryer load. Dryer, 4,800 VAs. We know that from 220.54 that when using the standard method for calculations, the dryer minimum is 5,000 VAs or the nameplate rating, whichever one's larger. So we add 5,000 for the dryer. Now let's do the range. Now the range load. In this case, we have an 11,000 VA range. In table 220.55, it tells us that one range figured from column C is calculated at 8 kW. So we add 8,000 to our load calculation. Now let's do the heating or cooling. the larger of the heating or cooling. Okay, so we have a 10 kW heat strip, and we have cooling at 18 amps at 240 volts. So our heating was 10,000. Our cooling after applying Ohm's law was only 4,320 VAs. And we're going to select the larger. Now we just add them together. We take our general, fixed appliances, dryer, range, and our heating, add them together, and that's going to give us 33,705 total VAs. And we select A. Now, just for fun, how would we figure out how many amps the house is drawing? We use our Ohm's law. Okay, we have 33,705 VAs. We're going to divide it by the system voltage, and that is going to give us 140 amps. Soon you'll know how to take that 140 amp figure, size the main breaker and the wire for a whole dwelling unit or commercial building. What is the total VA demand you would calculate for an 1,100 square foot home with the following loads? Garbage disposal, dishwasher, water heater, central vac, dryer, range, heating, and cooling. So step 1, you always figure your general square foot and your small appliance laundry circuit VAs first. First, let's calculate our general square foot VAs. We take 1,100 square foot, multiply it by the 3 VAs per square foot for dwelling units, and we're going to get 3,300 square foot VAs. Then we just add our 4,500 VAs for our small appliance and laundry circuits. Then we add them together. That is going to give us 7,800 total VAs. Now we head to table 220.42. We take our first 3,000 at 100%. So we take our total minus 3,000, set it to the side. That's going to give us 4,800 VAs. Step 2, we're going to take the next section at 35%. So we take the 4,800, multiply it by 0.35. That is going to give us 1,680. Step 3, we just add back the 3,000. That is going to give us 4,680 VAs. Great job. Now you're ready to continue with the rest of your load calculation. Now you do your fixed appliances. We have a garbage disposal, dishwasher, water heater, and central vac. In this case, there are 4 or more, so the 4 or more 75% rule does apply. First, add them together. Then you're going to multiply it by a 75% demand factor. That's 6,800 multiplied by 0.75, and that's going to give you 5,100. Now just add that to your calculation. Now do your dryer load. Our dryer's 5,200 VAs. We know from 220.54 that we have to use the 5,000 minimum or the nameplate rating, whichever's larger. Now the range load. Our range is 13,000 VAs. Table 220.55 tells us that ranges that are above 12 to calculate a 5% multiplier for each kVA above 12, like we learned previously. So the total percentage shall be increased by the column C number for however many ranges there are. So in this case, we have 1. We are also 1 over 12, so that is going to give us a 5% multiplier. So we go to column C for 1 range. That's going to be 8 kVA, and we increase that by 5%, which you just multiply it by 1.05. That's going to give you 8.4 kVA. Now we select the larger of the heating or cooling. Heating is 5 kW, cooling is 22 amps at 240 volts. So we are going to select the larger. In this case, it is the cooling. We just used Ohm's law and multiplied 22 by the system voltage, which is 240, and that's going to give us 5,280 VAs. Now we just add them all together. It's going to give us 28,660 total VAs for this home. And we're going to select C. What is the total VA demand you would calculate for 9 1,600 square foot apartments with the following loads? Garbage disposal, dishwasher, water heater, dryer, range, heating, cooling. So don't get overwhelmed. You're just going to apply the same steps. It's just a little bit larger. Step 1, first you figure your square foot VAs and your small appliance laundry VAs. First, calculate your general square foot. In this case, we had 1,600 square foot per apartment. That multiplied by 3 VAs per square foot for dwelling units. That's going to give us 4,800 square foot VAs. Then just add the 4,500 small appliance laundry circuit VAs. Add them together. That's going to give us 9,300 total. We have 9 units, so we are going to multiply 9,300 by 9, and that is going to give us 83,700 VAs. Now that we have our VA total for the general, we are going to apply our demand factors. We head to table 220.42. We take our first 3,000 at 100%. So in step 1, you take your total VAs and minus 3,000%, and that's going to give you 80,700. In step 2, you take the remainder up to 117,000 more, and you are going to multiply it by 0.35, and that is going to give us 28,245. In step 3, we add them back together. We take 3,000 plus 28,245. That is going to give us 31,245. Now we go for our fixed appliances. So our garbage disposal, dishwasher, and water heater, although it is only 3 appliances per unit, we are doing it on the whole service or feeder. So we have to treat the 4 or more 75% rule here. So we take our 9 units multiplied by 3 appliances per unit. That's going to give us 27 appliances. In this case, there's 27, so this rule does apply. You just add them together first. That's going to give you 5,500 VAs. Now, you're going to multiply that by 9 units and by the demand factor. So 5,500 multiplied by 9, multiplied by 0.75, and that's going to give you 37,125 VAs. Now let's do the dryer load. Okay, our dryers are 4,800 VAs. We know from 220.54 that we must use a 5,000 minimum. So we take 5,000, multiply it by our 9 apartment units, and we're going to get 4,500 VAs. Now we need to check for demand factors. We head to table 220.54, and we see that the demand factor is 55%. So we take our total VAs, multiply it by 0.55, and that is going to give us a reduced load of 24,750. Now the range load. Our range is 11,000 VAs. Table 220.55 tells us 9 ranges from column C. That total calculated load is going to be 24 kW, which is 24,000 VAs. So we just add that to our calculation. Now let's select the larger of the heating or cooling. Each unit has a 10 kW heat strip and cooling at 18 amps at 240 volts. So we do 10,000 multiplied by 9 units equals 90,000 VAs, and the cooling is significantly less. So we end up, after applying Ohm's law, with 4,320 VAs per unit. You multiply that by 9, and you're only going to get 38,880. So we're going to select the heating. Now we just add them all together. It's going to give us a very large number of 207,120 VAs. And we're going to select C. Great job. Okay, this week we're going to learn about optional feeder and service load calculations. Up until this point, we've done what's called the standard method. All of the rules about ranges, dryers, and everything have been the standard method. Now we're going to learn about the optional feeder and load service calculation. That's actually the name of it. You may be taking an exam and they're going to say, these are the parameters, this size house, this many loads, and calculate it using the optional method. The optional calculation we're about to learn applies only to single dwelling units. The optional family for multifamily dwelling units is very similar. It just uses a different table with different demand factors. Let's learn about dryer calculations using the optional method. How many VAs would you calculate for a 4,800 watt dryer in a dwelling unit using the optional method? So we've got some options here. We flip straight to our calculations tab in Article 220. When we're looking for something new, but we feel like we're in the right section, we're going to use our black bold headings until we pull out more keywords like we have before. In this case, obviously, we're going to look for something about optional calculations. Go ahead and take a minute now using your Calculations tab, head to Article 220, and I want you to look around for something about optional service calculations. And then if you want to continue, you can be more specific and look for optional dryer method calculations. So pause the video now if you need to, and we'll pick up in a minute. In searching, we find that 220.82, we're going to find the optional feeder and service load calculations. Everything in this section is going to be called the optional method. Now we need to look for optional dryer calculation rules. And we skim through Part A, we see nothing about dryers. Skimming through Part B, we find that we must use the nameplate of all appliances. I want you to go ahead and take a minute, pause the video, read Part A, and read Part B. This includes fixed appliances, dryers, ranges, and other such loads. So this method is a little bit easier. You just use the nameplate of the whatever the appliance is, and you can go on with your calculation. How many VAs, recapping, would you use for a 4800 watt dryer? We just read that you're going to use the nameplate, so you're going to select 4800. You will never use table 220.54 for dryers when using the optional calculation method. You have to remember that. So if they ask for 11 dryers and they're 4800 watts apiece, you got to remember, you just total them all together and that's your answer. How many VAs would you calculate for a 15 kW range in a dwelling unit using the optional feeder and service load calculation method? We find in 220.82b in Part 3 that we're going to calculate all the appliances at the nameplate rating. You'll never use the range table of 220.55 in the optional method. So you select 15,000. How many VAs would you calculate for a 3500 watt water heater in a dwelling unit using the optional feeder service calculation method? Once again, 220.82 Part B3, we calculate all the appliances at the nameplate rating in the optional method, and it's going to be 3500. How many VAs would you calculate for a single family dwelling that has the following appliances? 4200 VA main water heater, a 3500 VA additional water heater for the basement, a 1000 VA disposal, and an 1100 VA dishwasher. 220.82 Part B3 states that we use the nameplate rating, so the 4 or more 75% rule does not apply using the optional method. You're just going to total them all together, 9800 VAs, and you're going to select B. Okay, let's look at optional heating and cooling calculations. You will still select the larger of any of the two that are listed in 220.82C. If you want to take a minute, pause the video, read that part now. 220.82 Part C is made up of 6 sections. And for every type of heating or cooling that you're going to be dealing with, you just use the proper demand factor listed in that section. What is the total VA demand you would calculate for a 1600 square foot home with the following loads using the optional method? Garbage disposal, dishwasher, water heater, dryer, range, heat pump, cooling, and we've got some options. Step 1, you always figure your general square foot VAs and your small appliance laundry VAs. First, do your general square foot VAs. So 1600 multiplied by 3 VAs per square foot, and you're going to get 4800 square foot VAs. Then you're going to add your 4500 VAs for your small appliance and laundry circuit. So these two parts of this process are the same for the optional and the standard method, except you're not going to do any demand factors for this portion until the end. Add them together, 9300 total. You do not apply the table 220.42 demand factors with the optional method. We apply one demand factor at the end. Okay, so now let's do the fixed appliances. Now the fixed appliances, we just total them all together. It says use the nameplate ratings in 220.82B3. Just add them together. We're going to get 5500 VAs. Note the 4 or more 75% rule never applies in the optional method. Okay, now let's do the dryer. We just use the nameplate. I do want to note that you'll never use table 220.54, the dryer table, for demand factors when doing the optional method. Now let's do the range. 11,000 VAs. We're just going to use the nameplate, and we're never going to use table 220.55, which is the range table, when we're doing the optional method. Okay, now we just add them all together. 30,600 total VAs. Now, what do we do anytime we have our total VAs? We always check for demand factors. And 220.82b states that all the loads under section B shall be added together and take 100% of the first 10,000 VAs, and the remaining VAs shall be calculated at 40% of that. So that sounds like familiar verbiage of what we're used to dealing with. Okay, so we got our total. Just do it just like normal. Step 1 is take your total VAs and burn whatever you have to calculate at 100%. In this case, it's 10,000. So 30,600 minus 10,000 equals 20,600. Then you're going to apply the second demand factor. You take 20,600 multiplied by 4.0. That's going to give you 8,240. Then you just add them back together. So 10,000 plus 8,240, that's going to give us 18,240. Step 5, you do the larger the heating or cooling. Okay, so we have 10 kW and 18 amps at 240. You can take a guess. It's going to be the heat pump in this case. And we're going to select the larger. Okay, our heating was at 10,000 VAs. Our general, after demand factors, was 18,240. Add them back together. You're going to get 28,240. And you're going to select D. I do want to note that this method is simpler, and often, many times have I been asked in an exam for the optional method. Some of them just want you to figure out the overcurrent protection and have already done all of what I just showed you. Some of them I had to go through, do the entire load calculation from scratch. So if you're in the field, your inspector's likely going to want you to be able to prove to him that you calculated a whole house using the standard method. Often you're going to come up with less VAs using the optional method, and he's going to want to show the standard method. So you have to know how to do both, especially for testing purposes. What is the total VA demand you would calculate for an 1,100 square foot home with the following loads using the optional method? Okay, so we have all of our loads here: heating and cooling, range, dryer, so on and so forth. Okay guys, step 1. We are always going to calculate our general square foot and our small appliance laundry circuit VAs. So we do our general. That is going to give us 1,100 multiplied by 3. That is going to give us 3,300 square foot VAs. Then we add the 4,500 small appliance and laundry circuit, and that's going to give us 7,800 total VAs. Step 2, we're going to do our fixed appliances. In this case, we have more. 220.82b3 states use the nameplate rating, add them together. That's going to give us 6,800 VAs. Now let's calculate the dryer load. 5,200 VAs. We're going to use the nameplate rating when doing the optional method. Step 4, now we're going to do the range load, 13,000 VAs. And we're going to use the nameplate rating. Now we just add them together. That is going to give us 32,800. Now we check for demand factors. And in 220.82b, it states that we should calculate the first 10,000 at 100% and then 40% of the remaining VAs. Step 1, take your total minus 10,000. That's going to give you 22,800. Step 2, you're going to multiply that by the 40% demand factor, which is 0.40. That is going to give you 9,120. Then simply add them back together. 19,120 VAs for the general circuits of this home. Step 5, you do the larger the heating and cooling. 5 kW and a 22 amp at 240. That is going to give us that the cooling is larger in this case at 5,280 VAs. Select the larger. That's going to give us 24,400 VAs after we add the both together. And we're going to select B. Now let's do a multifamily dwelling unit load calc using the optional method. What is the total VA demand you would calculate for 9 1,600 square foot apartments with the following load using the optional calculation method? So we've got the typical loads here. Don't ever be overwhelmed by these type of questions. Just go through the processes. You know how to do this, and the only way to master it is through repetition. Have confidence in yourself. There's nothing that you can't face. You can do this. Okay, guys, you can do this. It's just like doing a single dwelling unit, just multiplied by 9. So get your general and your small appliance laundry first. 4,800 square foot VAs. Get your small appliance and laundry in there. Add them together. Now just multiply it by however many apartments you're doing. In this case, it's going to be 83,700 VAs. Note, you do not use the tables to 220.42. We're going to apply a demand factor at the end. Fixed appliance. Step 2. Now let's do the fixed appliances. The optional method's easy. We're just going to use the nameplate ratings. We add them all together, and then we multiply it by however many units we're doing. So it's 49,500 VAs. Note, the 4 or more 75% rule never applies in the optional method. Same thing with the dryer and nameplate. Boom. And you're going to never use the dryer tables when using the optional method. Same thing with the ranges. Boom. Multiply it by the amount of units, 99,000. Let's do the heating or cooling. Okay, we're going to select the heating. Obviously, you just do simple multiplication. Select the larger. Now we just add them together. Now when doing a multifamily dwelling unit using the optional method, you include the heating or the cooling in the total. So I don't know why they switch back and forth. I guess they assume that once you get over so many units, they're not going to be all coming on at the same time. But in this case, you just group them all together and then apply the demand factor. So we take our total. After we have our total VAs, what do? We always check for demand factors. Okay, so that's our total. What's the demand factor for 9 units if you go to table 220.84? Okay, go ahead and take a minute, look there now, see if you can find it. 43%. So we just take our total, multiply it by 0.43. That is going to give us 157,122 VAs. And you select D. I told you guys could do this. Just focus, stick to the script, follow the steps. Doesn't matter if it's 9 units or 9,000. You just do the same steps and then multiply it by 9.